Okay, so for the couple of you guys that I'm meeting you for the first time, I started programming when I was 18 years old, 2 weeks after high school graduation for the local school district. Um, and I was put on a database and web project. I mean, no school districts had websites in 1997. I mean, it's very rare. And so did very early active server pages and IIS, IDC database connector and ODBC database into the student mainframe system, pulling from an EBCDIC file. And then I jumped on IIS, which got me onto Microsoft, and I've stayed on the Microsoft stack the whole time. So while I'm dabbled in other things, I've kind of just kept that focus on the Microsoft wave of technologies, and it stays to this day. And I'm the CTO and chairman for ClearMeasure, which is a Microsoft focused consulting company focusing on implementing AI, .NET, Azure, and everything in that ecosystem. All right, so today I'm going to talk about AI software factory, the concept, the pattern. This is not a product. This is not like, oh, let me get the code and let me do this exactly. It's really a way of thinking. And that's what I want to encourage you to focus on. Not what I'm showing you as a coding tool. Although if you go to GitHub, github.com/clearmeasurelabs, and you find the AI software factory repo, it's out there, sample code, feel free. But I want you to think of this not as a coding tool or let me go get the code and use this explicitly, but as an executive level architecture pattern for overseeing and optimizing software delivery in general. I think with the seniority represented in this room, none of you started programming yesterday. All of you have done significant things and have been in the software industry for a good amount of time. And you're not junior engineers, right? So this is a leadership topic. I'm encouraged about the makeup of the people in this room. And so this is a architectural pattern for overseeing and optimizing software delivery, and it's for orchestrating how software moves through an organization so that we can systematically increase throughput while keeping quality high. Okay. So what is this AI software factory concept? Well, in today's world, demand for change is increasing. Demand for software, if we thought it was high, it's as high as it ever is. For most organizations, the team size is mostly fixed, not elastic. You have a software team, and then you say, okay, let's do as much as we can with that team we have. And even with the promise of AI, we have not turned the corner where most executives continue to look and say, is it done yet? Is it done yet? And then the software group, no, it's not done yet. And dates are still missed. So with this AI promise, the leaders who are investing in it, well, the promise is, oh, wait a minute, things aren't going to take so long and it's going to move faster. And I won't just have to sit and wait. Oh, we have to wait until the end of this month. Oh, when we miss this month, will it be next month? When is it going to be ready? Right? Because AI is supposed to move faster, right? We can do things more automatically. So the promise of AI is not yet being realized in general in the industry. The fast movers, the people who are jumping into it, there's pockets of amazing stories, but in general, across the industry, and it's not even 12 months since when this big wave, and Cursor really was the first one in 2022 and 23. Cursor was kind of the first ones, and they have some early numbers from 2024, but it was just what, November, December of 2025 that the Opus model came out and everybody's light bulb went off. And so many people had their Opus moment when they realized, oh, shoot, I can actually give it something and walk away, and it wasn't utter garbage, right? So everybody had this moment. That was only November, December, right? And now we're coming up for half a year and looking, oh, shoot, this changes a lot of things. But we're also seeing how AI is dumb and it's stupid and it gives me code that I would fire somebody for writing if they actually type those. So it's a mixed bag, and we're learning, okay, how do we use it? Where do we use it? And where do we not? And so I'm proposing this as a pattern because every organization wants more software delivered faster. The problem's not the lack of ideas for software features or what the customers are asking for. It's the software delivery. It really is the constraint in a lot of organizations, the overall process. And the AI solution, it's not a drop-in product. It's not, oh, if you were only using this tool, you would be so much better. It's a different way of thinking. All right, enough premise there. Let's review why this is even important. And I have two demos. All right, so I'm leading up to the first demo, and then I'll do the second demo. All right, so a lot of organizations, they push for speed, and speed really fails as a goal. And actually, if you look in, I think it's chapter 6 or so of the 5 Pillars book that you have in front of you, there's a whole chapter on why you can't push for speed. Speed happens organically in the absence of rework. And so because AI doesn't do anything automatically, we can't just get more speed, get more throughput by just saying, oh, well, AI is going to do it. Defects, those consume capacity. It's rework. I thought that I took a good step forward. Oh, but then there's a defect. I was wrong. Now I have to go back and I have to try to take that step again. So that's rework. That's new work that I didn't think I had to do. Rework is new work. It steals from the current team's capacity and it distracts us from working on the next thing. The same thing with production incidents, stability in production. If it's just a training issue, yeah, your customer service can handle it. But if something's wrong in production, it goes right back to the software engineering team. And guess what? We thought we had good and stable software that would run reliably in production without disruption. We were wrong. Now we got to futz with it. And of course, it's the highest priority because something's wrong with production. And so escaped defects, lack of quality, and production incidents, which is stability issues, those two things are thieves. They steal our team's capacity to work. As long as there's a steady stream of either one of those, in the instance where there is a steady stream, team can't do anything because there's, oh, defect this, defect that, production incidents. And some of you have worked in a situation where management tried to cope by saying, well, let's have a backlog and let's have a bug backlog. I mean, there's so many that you're like, well, we're just going to have to live with it. And maybe we can teach the users some type of workarounds and just not fix them. But that's an underlying process architecture problem. All right. So you can't just go faster. You have to go well. And I'm talking about this premise because there is a whole lot of prior art that has come before the way of thinking that we have today in the industry. And even before DevOps, before cloud and infrastructure as code, before Scrum, before extreme programming, the books, these are really, textbooks of the industry. The goal by Eliyahu Goldratt, he introduces in the book, The Theory of Constraints. And so much of our software process today is based on the theory of constraints. And then systems thinking and feedback loops and Edwards Deming's quality management. The ideas came from manufacturing, lifted into software. And then the Toyota way, which really came from Taichi Ono's Toyota production system about flow and elimination of waste. And so in the software world, a lot of people have used the term frictionless development or removing friction. All those ideas, they came. And so this I bring this up just to remind us of some really big ideas that have come before us in the industry that are still just as true today as when they came out. And then, of course, there's been all kinds of other books. This is just a smattering of books that have those other books in their bibliography. And there's many more that cite the work of those previous books. Okay, so everything that we do about the process for how to deliver software well, it goes back to this heritage. All right, AI doesn't change any of it. It builds on top of it because we're still taking ideas about what we might get a computer to do, and we're still doing a series of activities, and then we are putting that computer that does that thing into a business setting and wanting it to continue to run in a reliable fashion, and also to measure, were we right? We had a hypothesis about what we'd like the computer to do, and that would help our business. Okay, let's do it. Now we have it and it's doing it. Were we right? Did it help? It's not always a yes. There was a very important study, in my opinion, that was conducted with teams that were doing Scrum, and they looked at the product owner deciding what needed to be done and then putting it in production, and found that about a third of the time, this hypothesis about what should be prioritized, about a third of the time it helped the business. About a third of the time, it had no effect on the actual business outcomes. And about a third of the time, it was completely wrong, and we needed to undo it as fast as possible because it actually hurt the business and what we were trying to accomplish. So this notion that we can decide up front what we want the computer to do and we're going to be right, that is a falsehood. It's a hypothesis, scientific method, right? We come up, I think, if we get the software to do this, if we add this feature, if we change the architecture this way, I think it will turn into more revenue, less expense, faster orders, whatever is beneficial to the business. We think it'll happen, but we have to measure. And so open telemetry is not just about figuring out if the computer is still happy and still running. Open telemetry is about understanding what's happening, and when we apply it to a business sense, then we can get the answer to that hypothesis at the beginning. All right, so there's a lot of setting the stage. Let me introduce this concept of the AI software factory. All right, so I mentioned it as an orchestration pattern. It is a software leadership orchestration pattern. We have other orchestration patterns. We have continuous integration that orchestrates our builds, testing. You know, is this, we made a change to the software, is it still good? We have automated deployment, a series of environments, and we deploy all the way to production. That's an orchestration pattern that's matured. We kind of understand how to think about that. The concept of an iteration or a sprint, that's a team delivery orchestration pattern. And so the AI software factory is an end-to-end delivery orchestration. In your mind, and a lot of you have toured the Dell manufacturing facilities in Round Rock, but in your mind, think of an actual factory. And by the way, yes, Dell puts out computers, but they're made to order. It's not just putting out cogs. Every computer is different, okay? Even though there's common architectures, okay, every software feature is different, but it's common sets of libraries, common architectures. Hey, we're going to use C# for how many of these features? All of them. You know, so in any kind of progression of work, you want to find the commonalities to make as much of the work similar so that every unit of work is not completely different, right? But in the Dell factory, there are multiple production lines, and they may be on a different computer architecture, but the concept is the factory receives just raw materials, hopefully common raw materials, and can set up different workflows, and people do different things and do some stuff, and then verify all these different computers. They burn them in, and the supervisor of the factory, the plant manager, does not have the capacity to go and check to make sure that every stick of RAM is properly seated in the slot. Nobody checks to see if the RAM. Instead, they have automated tests. They turn the computer on, they have burn-in, they run the computer, and they execute a bunch of stuff. And guess what? If all those pass, we know that the RAM is properly seated in the slot. Okay, So just like automated tests for software. And then at the end, we say, okay, this is ready to go. Let's move it on. All right, the only difference there is sending out a product as opposed to, okay, now that the computer is good, let's run the computer for the customer. Now, if it goes to Azure or AWS, well, now they're running the computer for the customer. Okay. All right. The posters that you see here, this is just the top 1/3. This is an AI DevOps architecture poster. I bring it up first to stress the point that AI-driven development is not possible if you don't have certain prerequisites. If you don't have continuous integration as a pattern, then you don't have a way to validate at different work cycles if the change that was just made is a healthy change or not. Okay. And so whatever AI tool is changing code, well, guess what? That tool is just saying, hey, I'm done. I changed some stuff. But if the AI tool has a way to run a command that is the build, well, now when it fails the first time or the second time, okay, do a few more cycles, because we don't want to waste any of our time unless the code is actually functioning and meets certain standards. Same thing with the progression of environments all the way to production. Having a complete DevOps environment, I'm just going to say it, is an absolute prerequisite to graduate to the level where you can do AI-driven development. All right, so it's a maturity on top of a complete DevOps environment. If you walk into or inherit a certain piece of software that is still struggling with test automation, or the build takes 45 minutes just to get through, and even then, not every part of the system is fully tested, then that situation is not yet ready for AI-driven development. It's not even, if a manual cycle is really slow, then trying to make it an AI cycle isn't going to speed it up. It's probably just going to attract a bunch of AI slop and break more things. All right. Okay, let's get into our first demo. So I'm going to put PowerPoint away. And I'm going to go over to, all right, we have an application here. And I'm going to restart these guys. All right, we have an application here. It's running in Azure. And let me just bring it up. Just to show you, it's a simple work order application. I use it for training. I've actually, this general concept I've used for training since 2009, I think. And it's got to warm up the Azure Container app, which I think is sleeping quite soundly. And so it's, all right, starting it up. It's scaled to 0. Okay, let me shrink this down. All right, it's a work order application in the theme of the First Church of Springfield, and we can log in as any number of people. And let me just go. Let me find, where is Reverend Lovejoy? Where is it? Timothy Lovejoy hiding. There we go. Timothy Lovejoy. All right. No password, just sample app. Okay. And Timothy Lovejoy can look at different. Oh, this color scheme. This color scheme is off a little bit. All right. We're going to say new work order, or I can go to my work orders, and I can see all the different work orders that I've assigned. I've assigned something to groundskeeper Willie, and mow the grass, and I can cancel the work order, or groundskeeper Willie can log in and he can begin it. All right, that's enough of looking at the application. This is the health check endpoint. So if I refresh, I can see that, okay, the application's healthy. Overall status is healthy. Each one of these is an individual health check that checks something different. It's just using the .NET health checks library. Okay, so now I'm going to run this straight from, let me get rid of this Copilot window. I'm going to run this straight from Visual Studio. And just close. No, I don't want to save. It looks like, okay, Control F5. Now we have this configured to go against the GitHub Git repository that for this work order application that's stored in GitHub, and we also have a we also have a project that doesn't have any items on here, but it is for the application. All right, so if I run it, let's see. Okay, this is Aspire. It runs some things. In Grok is so that I can have a dev tunnel so that GitHub webhooks can actually call back to my computer. So that's why that's there. And let's just open the front end, and I'm gonna quickly create some demo work items. All right, so I'm over here, and this is my board, and I'm just creating some sample work items, and you can see them popping up on the GitHub board. All right. We all have cards that we work on. If I go, let's see, force capitalize or add, navigate, hide button. Let's open up this one. And I'm actually going to remove it from the demo list. And I'm going to mark it for the AI factory and say, okay, it's ready to move. So if I label it as such and I come off of here, then it because it's marked, it should be picked up and it should be starting to work on it. Yeah, you can see that it just got moved over, okay? At the same time, if I come over here, I have a way to basically corrupt some memory in the application. So I'm going to hit that button. And so if I come over here and refresh my health check, we can see now that we're unhealthy. Why? Because there's some memory that's corrupted and there's a health check that sees, you know what, the memory's corrupted, restart the process. That happens, right? I gotta kick the server. And if I kick the server, everything, it'll restart the container, it'll be good again. But right now, it's unhealthy because I just sabotaged it under the covers. All right, so something in right here. Nope, I went over here. Something in production. Let me go all the way over to the end, and we can see that a production incident just popped up because we have, a monitoring tool that is checking the health check endpoints. Like, oh, and because it's an item that's in our knowledge base, it's not that hard. We kind of understand this. We've routed it to a work item, and we've chosen to put it in the release queue because we don't need a new build. We don't need to put it early in our work tracking board. And by the way, let me just go over this work tracking board. I'm gonna do this. Actually, while I do it, before I do that, let me show you what just happened because it already got worked, and we can see that we have some narration here. We have some comments that says that the AI factory cursor has been matched for this work item. So we've got cursor, the sample has Copilot SDK, and it also has the cursor API for cloud hosted sessions. It's immaterial whatever tools you use. All of them have programmatic session start these days, where whatever tool you're using, you can just write a little bit of code and say, hey, start a session, here's the prompt. And so the cursor session started. If I click on this link, it'll actually open cursor, and I can see that there was the prompt, and I can see that cursor actually went through and did some stuff, and it actually ended up resolving it. And if we go back to the health check, which was unhealthy, if I hit Control F5, it went and it rebooted the container, and now the memory is uncorrupted and we're healthy again. Okay, so that sequence. And I show you that example because every single one of us that has to care if a production environment is healthy, we always have easy things that happen, right? Now, the hard things that happen, no, the AI tool is not going to figure it out. But the easy stuff that happens that just steals our time, where we have to just, restart a container or do fiddle with it, and it's the same thing. We all have those scenarios. And the state of all of the AI tools right now is if we just did a little bit of orchestration, those things could be completely automated. And this is an example of one where there's a health check. Which health check failed? Based on which one it is, we can do a little bit of AI inference, grab some logs, feed it into a prompt. It's like, hey, do we think that we know a common solution for this? Yes. Okay, here's a little tool or here's a little PowerShell script that resolves that if we're right about what's wrong. Okay, run the PowerShell script, which restarts the container. Did that work? Yes, it worked. Health check is happy. Great, production incident is over. Nobody on the team had to spend any time. Okay, so what we say about speed, speed is emergent, and time wasted with escape defects steals the team's time. Time wasted with production incidents steals the team's time. So that's just, so I want you to grab on. That's one example. Every one of us in this room is probably going to have a dozen examples of things that happen in production that are not hard. Okay, that's the low-hanging fruit. That's the low-hanging fruit. Get the easy stuff and just automate those scenarios. But at the same time, again, this is a pattern. So what I want you to think about is as you automate it, make sure that whatever bot is doing it, whatever little coding robot AI tool is doing it under the covers, make sure that you do journaling of what's happening so that when we look at, oh, what just happened, it's not opaque. That we can see, oh, this is actually what happened. It got identified as compatible with cursor. It got routed to cursor. We can even go to the cursor logs if we wanted to. When cursor finished, it was, yeah, work complete. We can see the work summary. I mean, I could have manually typed in the prompt and manually waited for the tool to do it, or just let it do something that's easy. All right, so that's one point. And okay, if I go to this guy, I need to mark him as ready to move. Okay. And then also I'm going to label all issues. All right, I'm gonna basically approve all the issues. I'm approving all the issues as ready to be worked. And so if I come over here and minus, all right, we should start seeing some movement, but let me talk about the board. I know you can't see the text. I know you can't. But this column right here is our development column. All right, it seems pretty big, but the development column is where code is changed. We create a branch, we do some branching, we run some build. The columns to the left of that are figuring out what code to change. The columns to the right are, I changed something, is that good? All right, so requirements, analysis, design, test design, whatever is appropriate in your situation, there always tends to be different concepts. It's, figure out what we want to do from the business standpoint. Then it's figure out how a person might experience that change once it's in there. Then it's figure out how to technically implement whatever that is. And then it's decide what the definition of done is. That's basically test design. Okay, if it were done, what would we do to make sure that we're happy with it? And once we make all those design decisions, it's pretty darn clear what we do from a development perspective, right? Okay. Now, from a pattern perspective, see if I can go into here. Was it add navigate? Which one did I mark as? No, it wasn't that. Let me do a new one. Let's add a new work item. What do we want to do to this? Let's see. Put Austin in the title of the homepage. That's an easy one. That's an easy one. Now, if you're thinking, why don't I give it a hard one? Well, it's because AI is not smart. It's artificial intelligence. Sometimes it's actual idiocy. All right. So let me just mark it. Let's see here. This is an easy one. Now, the whole point is, all right, the whole point is low-hanging fruit. We all know that we have to evaluate and there's a lot of bad things, but for really easy stuff, the models, there's a set of models that are really, really good at easy stuff. If I look at something and say, oh, there's a spelling error on some type of screen. Does anybody with any kind of programming acumen actually need to be the one to prompt the AI tool to do it? No. We just have to have an understanding of what the right process is for getting that spelling mistake corrected. And if you think about it, even the business analyst or tester who noticed that there was a spelling error on the screen, if equipped with the right process, could put in the right information that would become the prompt to the AI tool to, hey, go and fix it. And the AI tool will branch, okay, change it, fix the spelling error, create the pull request, wait for the build to succeed, build succeeds, okay, mark it, hey, it's ready for PR review. And then it's like, okay, merge it in, we're good, right? So think about the easy stuff, not the hard stuff. For the hard stuff, we don't even know if we've broken it out into all of its subtasks. So I'm not talking about the hard stuff. I'm talking about the easy things. If we can take the easy things and literally not spend any time on them, now what happens to throughput? Okay. So again, and it's not about the tool. I know you look at this like, oh, some things are automatically going across the screen. From a technical perspective, GitHub is saying, oh, I labeled something, and it's calling a webhook back in the software, which is sending a message to an in-service bus queue, which is then looking at the item and saying, oh, is this routable to any of the AI tools? And say, oh, it's routable. Okay, let's use cursor. What's the prompt for this column? And then it's starting up a cursor session and delegating to it. And then cursor calls back to the API and says, I'm done. And this calls back to GitHub and says, hey, why don't we mark it as ready for move? Let's move it over one column and then another webhook. So there's a bunch of little orchestration happening. That's not the interesting thing, because I think that all of the tools and all of the commercial vendors are going to build orchestration into all of the products. And we already see it happen. Okay, so to implement this pattern, I don't think we have to do this orchestration. I think the commercial vendors are stepping up their game and they're going to do the orchestration for us. I mean, with Copilot already, the squad implementation already has a preview of pointing Copilot to a particular column on your Kanban board and saying, hey, anything that drops in this column will automatically be dispatched to Copilot in autopilot mode with the squad agent. Or I think all of the tools are probably going to do that, and they're going to do it well. All right, so I don't think we have to do that. But what we do have to do is figure out what our process should be and what type of work we should let go to the AI tools. And so if I just, let's see, on the homepage. Okay, so let me interrupt this guy. Notice that I only put Austin in the title of the homepage, right? That's all I put. So where all the rest of this come from? Well, user experience design. In the user experience design column, Cursor combed through the existing code base and basically harvested from the documentation, the README file, the markdown files, the code, what was likely the best way to come up with a plan for user experience. And then technical design. How are we going to do it? Well, guess what? Look, it found the actual file that was the homepage, index.razor in this Blazor application. And it also found index.html for the title tag. It found landing page tests because we have Playwright that's checking for some particular tests, and index page tests because every test has an automated Playwright test that goes through the browser. So it found that those were the 4 things that likely have to be changed, and some patterns and conventions, technical constraints, and then what's out of scope. So all of the AI tools have a concept of plan, implement, right? They're all kind of agreeing on that okay, we create a plan. What's a plan? It's actually a pretty detailed prompt. So we do a little bit of prompting and reading to create the implementation prompt, and then we give that implementation prompt, which is a plan, and that becomes a prompt to go and do this. So this super easy thing of change it to Austin, well, as it moves across the board, the user experience prompt comes through, adds some stuff, then a different prompt finds out technically what files need to change, adds some stuff, and then goes through the whatever agents, MD, Copilot instructions, README files, whatever thing contains our team norms and how we do things, adds it in there. And now this work item that was just add Austin to the text Now this is a pretty detailed prompt. Now I can go to implementation, and pretty much any of the AI tools are going to do a fine job doing this. And now it's a branch with a pull request, and we can just check. It's like, oh, is that good? Okay, good. All right. So in effect, the orchestration goes column by column and builds up a plan. So instead of us manually doing plan mode and then implement mode and like waiting for it, we can just let it be automatic. Again, for the easy stuff. I'm not talking about hard stuff. I'm talking about the easy stuff. Think about it. Think about it. If we took all of the easy stuff and just figured out the touch points to let it be automated, where anyone could say, hey, this thing is misspelled, go fix this, or hey, we just started offering our products in another, in our 34th state in the country, go add that state to the drop-down menu somewhere. Just there's a ton of easy things. And if a product manager, if an analyst, if we equip them with the process to put it in the queue, and then pull request came up, all of the checks and builds are green, and a person on the team would have had to do it, right? And as long as it's in this way, it's coming out just like we wanted it to as well. Now, I talked about prerequisites. None of this happens if you don't have a build, if you don't have adequate test coverage, if you don't have a clear branching strategy with some type of review process. So you have to have a complete DevOps environment and process, and then we can layer on AI orchestration on the top of it, regardless of what tool you use. Again, I don't care what kind of tool. All of the tools are getting better. I think they're all going to automatically do some orchestration like this, where you won't have to sling some code that I'm showing you in the code sample. Okay. So, by the way, I'm going to break production again, and we should see another production incident pop up. There we go. Okay. All right, let me go back to PowerPoint. Okay, that was demo number one. Now, yes, sir.
Production, right? Just for production. What use the trigger now? Fixing that.
Oh, sure. It's just a little worker that's polling on a timer and hitting the health check endpoint. It's hitting the detailed health check endpoint, and if unhealthy, it's harvesting logs and telemetry, what's available, and it's basically it's calling the GitHub API to create a production incident work item, putting it in the column that we have it configured to put in there, and done. And just put it there. Then, technically, GitHub calls a webhook that's like, hey, there's a new work item of type production incident. Calls the webhook in my software, and say, oh, the production incident. Okay, what should we do with it? And where should we route it? And then because I have a cursor prompt configured and to check, are we compatible? Yes, we're compatible. Okay, let's create a cursor session. So it's kind of the flow. Yes, sir.
So in regards to is there like something like this is like a low-hanging fruit versus this is something really complex, or
yeah, so in my code sample, I only have the one. But from a pattern perspective, the prompt needs to have, well, in this case, the prompt is evaluating and saying, can we route this for automation? Well, if in this case, it's matching some text for this particular health item says the memory is corrupted, restart the application. And so the prompt that evaluates it is coming back and saying, yes, I can handle this. Yes, I can do this. To cover all of the possibilities, I think that you're going to need whatever your knowledge-based system is. You're going to have whatever connection it is so that it doesn't give you false positives on the wrong things or the false negatives on the wrong things. But it's a prompt that makes a guess. Can we attempt to handle this automatically or no?
It looks like you have you said you have
PowerShell script, you have like deterministic tools you've given it. Say, like,
Thank you. Do we have deterministic tools? Thank you. The AI tools are running large language models, which are non-deterministic language processor predictors. All right. They're pattern matchers. They don't know anything, and they don't follow instructions. They don't know the meanings of words. They just know that when you say a word, maybe some other words might be the next thing. And so the concept of guardrails, there are so many stories, you probably heard some of them. There's so many stories where someone says, well, I was told to use guardrails. And so I used guardrails, but it ignored the guardrails. I'm sorry. English sentences have no power. There's no such thing in a large language model prompt as a guardrail. It's all just language and pattern matching and predicting. If you need a guardrail, it has to be deterministic, just as an architectural concept. Okay, you can't take a non-deterministic architecture and expect it to always do something or never do something. Doesn't work. You need a deterministic guardrail. What does that mean? That means if I never want it to drop the Pocket OS production database for my entire company, then I need to make sure that it doesn't even have access to call the API, or it doesn't have access to, it only has a read-only token, right? That's an actual guardrail. You know, if it tries to do something that would write or edit, it'll get an exception. That's a guardrail. So I know that so many people are still hanging on to this concept of prompt engineering and tell it what to do. But then you hear all these stories of, well, why didn't it well, you don't even know if that sentence got loaded into the context window to start with, because that's not deterministic. All right, you got to remember, this whole architecture is non-deterministic. It's probabilistic. You don't know what it's going to do. So when we're putting together our whole process, if we always wanted to do something or never wanted to do something, we have to use code, whether it be PowerShell or anything. Okay. If we wanted to guess at something or transform something, okay, now it's going to shine. Now it's going to do a great job at taking an input, transforming it to something else, or making a guess. Do we think that we can handle this production incident? Make a guess. And if it's greater than a certain percentage, yeah, let's route it and make an attempt, right? Good question, though. Okay. And the rain is really coming in outside, making more noise. Yeah.
Are you investigating?
So no, that's a good point. MCP. Are we using MCP? Yes. I don't have. Yes. I don't have MCP in this demo, but yes. And the way I think about it is seems like there's 3 categories of family for an AI harness to integrate with something on the outside. And the reason I say AI harness instead of a large language model is because the language model just replies back and says, hey, I would like this tool called, or I would like this MCP endpoint called, or I would something like that. And so the 3 categories that I think about how I group them is I think about them as remote MCP servers that have tool calls. I think of it as web APIs that can be called just with an HTTP or a call, web fetch, curl. And the third is EXEs, actual command lines that are on the computer that's running the AI harness. Those are kind of the 3 categories that I think about when getting whatever's running my prompt to call out to something else. So I don't have a demo. The way I think about when to reach for an MCP server is when it's not feasible to get something installed on the computer that's running the prompt. If I can have something installed on the computer that's running the prompt, then I can just have a PowerShell script or an EXE tool local, and I can just call it locally. I don't need to mess with the orchestration of an MCP server. But I think that's where the gap fills in. We're getting some really good rain. Love it. Okay, I'm glad I brought the loudspeaker. All right, let me get to the next demo. And if somebody says something, I didn't hear you. Okay. Okay, let's get to the second demo. Actually, I want to say one thing. Core capabilities of the AI software factory pattern, core capabilities is clarity on what I have and what is happening. All right. Second is the ability to change what is happening so that I can affect what I have. And the third is the ability to forecast, if I continue going like I am, how is the project going to go in the future? Okay. So now we see, like, that's the leadership topic. We started with the techie demo where, we can connect some cool techie stuff and we can do some automation. Great. That's interesting. Cool. But all the tools are getting better. So great. We can automate stuff. Why? Because we want to go faster. We want to deliver more. In order to do that, we have to lower defects that escape, and we have to increase production stability so we have fewer production incidents that are distracting us. So the capabilities I want to focus on is the next demo is all about clarity and improving and then forecasting. All right, so I'm going to jump right into the first part of this next demo, which is clarity on how fast we actually are going and how our escape defects and production incidents affecting us. Okay, so let me go back to this. Okay. If I go over to this is the Clear Measure Intelligence Scorecard module. And if I group by minute, you will see that we have a scorecard. Every column represents a different minute. And while things were happening under the covers, it's counting up how many work items moved through. We weren't tracking defects, so nothing is there. And we had, just that one production incident in a recent minute. And then we had another production incident. If we click on it, we can see that the actual production incident. If I click on the link, it'll go to the actual work tracking system, and we can see the actual production incident with the journaling of what happened, including the link to the cursor session for full traceability about what we did about it. Okay, so we have that. But let me reset. I have a simulator here, and I'm going to reset the data. That was clear all data. And I want to actually simulate what we really want to track for our teams. So I've got a tool that just basically generates a whole bunch of records of activity. I'm going to configure it for 10 developers working 8 hours a day for 60 days. And I have some other things like every third work item delivered to production, there's one defect that escapes. Every week, there's 3 production incidents of some kind. So they're not doing pretty well. And then I have some, like, how many minutes per column. It's just a simulator. So I'm going to hit go. And if I go back to, if I open up the scorecard, a new tab, I'm going to switch by week. I'm going to do the columns by week. And it's going to run for 60 days and really quickly simulate this thing running. If I can go full screen, there we go. Okay. All right. Some of you in this room have managed or are managing complete software groups. And the executives who run the company, they run the entire company with financial statements. They have a balance sheet to answer the question, what do I have? And then, what do I have and what do I owe? Like real debt, not technical debt, but real debt. And then they have a income statement, which answers the question, how are things going? And the income statement, based on what happens there, that affects what I will have on the balance sheet and what I will owe on the balance sheet. Okay, so the concept of running the entire company by numbers is a normal thing with top business executives. Well, with software groups, what is keeping us from being able to answer the question, when am I going to be done? When is it going to be done yet? And hey, if we started this new project, when could it be done with? What prevents some groups from being able to answer those questions is the lack of the equivalent of financial statements for the software group. Okay, so I'm calling out the scorecard. All right, it's just numbers, and every period is a week is a common period. Some people have 2-week sprints or iterations. Whatever common size period you want to use. All right, so we're simulating how much new work for this particular week. How much new work came in? There were 14 items, and then 23, and then 15. And then this team had some rework. It's important to measure rework. What is rework? It's when something went forward on the Kanban board and then it went backwards, right? We thought that we had promoted it and we thought that we'd done good work. And then we found out that we were mistaken and we still had more work to do. Yes, sir.
So it looks like you're, maybe not all four, but you're basically measuring DORA.
Yes, thank you. Thank you. The DORA metrics are represented here, except for deployment frequency. This particular chart does not have one of the 4 DORA metrics, which is frequency of deployment. But yeah, exactly.
That maybe nowhere places actually have the hard numbers across the company for the DORA. So I think that's pretty cool.
Yeah, mean time to delivery. So we have the common sizing. If I scroll up a little bit, we're rolling up 4 weeks for the roll-up period. So across a 4-week average, our mean time to delivery is 0.93 weeks. What that means is if somebody asks the software team to do something new, it's going to take roughly 1 week in order to get that done. Okay, and you can count on it. Now, so many teams will say, yes, but then there's large features and then there's spelling mistakes and they're not all the same and you can't do this and you can't. Okay. But at the same time, we never code big things. Or if we do, we almost always agree that it was a mistake, don't we? When we get something new, by the time it comes to actually creating a branch, changing some code, submitting a pull request, if somebody gives a monster pull request, no bueno. We all agree that, oh, that was a mistake, right? So we all agree that by the time it gets to the point where we're going to create a branch and write some code, whether I do it with my finger, whether I do it with ReSharper or AI, it's going to be a manageable, smaller set. And so if it is this big, amorphous, undefined request, we're going to talk about it and we're going to break it up. And we're going to split, we're going to split, and we're going to split. And by the time we've split it into reasonable chunks, okay, now we understand the definition of done. Now we figured out the piece parts. And now we've sequenced the work and we implement it 1 chunk at a time. That's normal, okay? So at the very beginning, if you just have a backlog full of, I want to compete with Amazon, go. Okay, not actionable yet. We need to talk about what that means. Yeah, you can't factor in that. But by the time you get past technical design, that's the point where you think, how am I going to implement this? And in order to answer that question, we break it apart. We figure out there's chunks to implement. And now at that point, whatever the count of those items are, they're pretty similar. And any one of them, according to these numbers, takes about a week to implement. Yes, sir.
Why wouldn't you also just have like a measure of impact? I mean, you say the impact of this is like there's 3 dependencies impact or not the one. If you have a measure of even the small items, their barns, their also measure there also.
Yeah, absolutely. Absolutely. Yeah. If in a particular setting, there tends to be a stream of work that is always reliably tiny. Yeah, we could categorize and we could split this metric and we could have, hey, what's our metric for the tiny items and what's our metric for the normal items? Absolutely. I mean, these numbers are, there's nothing magic about these numbers. The numbers need to give us clarity about how things are moving through. All right, so I just simulated these numbers based on a team. Let me go back to the dashboard. Let me forecast forward. What I'm going to do is we are going to simulate doing some things to get better at quality and doing some things to get better at production incidents. So I'm going to get better. All right. And we are also going to introduce some low-hanging fruit AI automation for simple work items. I'm going to say that AI is going to do some of the UX design, some of the technical design, some of the test design. It's going to do the lion's share of the development. It's going to do just a little bit of functional testing and just a teeny tiny bit of UX testing, but then a lot of the release queue. All right, so this is simulating getting AI tools to just do some of the low-hanging fruit. And I'm in forecast mode, and I'm going to start forecasting forward. All right, so as we come through here, what we saw was throughput was in the 14s, and the mean time to delivery was 0.9 something. So we've made some improvements, increased our quality, lowered the number of production incidents. And what we can see is our throughput has climbed past 14, past 15, now averaging 19. Mean time to delivery was a week. Now it's down to 2.5 days, 2.5 business days. And so this is where you might be interested in grabbing this sample code. If you create a scorecard that harvests what's actually happening from your work tracking system, whether it be GitHub projects, Azure boards, Jira, Zoho projects, or Zoho sprints, or whatever, all the work tracking systems have APIs where you can vibe code some calling out and just grab the data and then make your scorecard. With that, you can forecast forward and you can say, if this track record stays the same, if we continue to take on average just about 1 week in order to deliver a new work item, or if we tend to, with the whole team, deliver 14 work items per week, then, fast forward, now let's ask the question, how much can we get done in the next 6 months? If we keep on working the same way with the same team composition, now we can forecast forward. And so we went from a throughput of 14 to 18.25, and we went from a mean time to delivery of 0.93 to 0.29. So I mentioned the ability to make changes and then know that it was a good change. If we're going to implement an AI tool, that's a hypothesis. I think that it's going to affect our performance in some way. But if we don't have clarity on what's actually happening now, we don't know. The CFO knows we spent money, right? We spent money on some AI tokens, but how do we prove that there was any kind of return on investment, right? So however you do it, you need some type of scorecard like this to track for yourself and to be able to report out. All right. And a few niceties. One thing that I recommend as you do this is, actually, I'll hold that. Okay, this was simulation. I am going to kill the application. We'll see if the electricity holds. I'm going to kill the application. I'm going to set a different project as a startup project. Where is it? Control F5. Okay. So we are actually going to hook into an Azure Boards project of a real client that we did. This was a project that started mid-2020 and it ended in 2022. One of our clients has majority market share in county fairs nationwide. And so when people couldn't gather in county fairgrounds in 2020, Guess what? There were a whole lot of FFA kids and 4-H kids who had raised an animal and it was ready to sell at the youth livestock auction. That's a big deal for these kids. And so we partner with this client and did it come up? We partner with this client and we created an online auction simulator application with real-time messaging using, SignalR for, instant bid updating, embedded videos. You can have an auctioneer actually barking and thanking sponsors, and as people are winning and announcing, and everybody's on their phone, like, bid. It's basically like raising a paddle, but so, yeah, we did our best, right? Because to get all those animals sold. Okay, I think, did it start up? No. All right, let me try again. Oh, here it goes. Okay. Starting up. It's odd that it's taken this long. All right, let me try again. Maybe something's wrong. All right, Control F5. That's a little bit quicker. I don't know if that was the case at all, but did this 100 times today, and yeah, all right, no .NET processes. Okay. AI tool. Okay. Running and give me the green light. All right, okay, so this is what I need to do. I need to go over here. I need to clear the data because clear all data. We simulated a whole bunch of stuff and we're going to change it to a custom range. And I'm going to do 2020 and 2022. And we're going to harvest all of the work items and the work item history from Azure boards. And by the way, every work tracking system has APIs that allow you to get the work items and the revisions to the work items. And I remember, in, what was it? 2019, I wrote the book .NET DevOps for Azure, and I have spent a lot of time writing code against the Azure DevOps Services APIs. I will never do that again because that code is super easy to generate. You have a method, it's like, I want to get this, and WQL, it's like, boom, 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 right? So it's not hard, like, doesn't matter what work tracking system you use, easy to integrate now. You just generate the code, bounded by a class, you're good. Okay, so we are pulling 2 years of work items and all the changes of the work item from this is the real project board, okay? And again, there's nothing magical about how we put this together, but it's a pattern. You need to have something that gives you this ability to get these real numbers. So if I were to go way back in time to the beginning of the project, we can see that at the beginning, 235 new items. Hey, here's all the stuff that we need to do. Let's get it into the system, right? We hadn't written any code yet. '20, and you can kind of tell when we decided to get a little bit serious about, come on. By the way, I'm remote desktop into my home computer, so I'm hoping that the internet is not going to wobble.
This is real data about it.
Real data from 2020. And I'm wondering if remote desktop just flaked out. Or if the Wi-Fi just flaked out. It's not doing anything. Do I have, well, it's still working. Okay. Okay, I got some internet. Okay, you can tell that we started tracking some defects. So if I just go back to the right and let's just pick one. All right, some throughput. We finished 5 items. It's nice to be able to say, oh, we finished 5 items. What items were they? Okay. And then, oh, Azure Service Bus error logging for the dashboard. Okay, which item was it? Or auction monitor. Okay, let's click on it. Let's go to the actual work tracking system, which we have permission from this client to share this. I mean, the virtual auction shut down because it was, now they can go to the actual fairgrounds. All right, so this is the actual work item. We can look at the history and we can see, okay, what actually happened on this work item, switches. I mean, it's a bunch of stuff. All right. So if we come back, we see actual defects that escaped. If you look at the mean time to recovery for an escaped defect, it was, I mean, we were kind of a shoestring team. It was, 2.5 weeks on average. Now, because that's a lot of work items. If we would have had this clarity back then and been looking at it, we would have said, well, that's not right. Oh, why is it? Well, because we let these defects sit. We didn't properly say closed won't fix. We just left them in the column and ignored them, but we knew that there's an easy workaround. Some other feature took care of it. And so, all right. And this particular project did not track production incidents in Azure DevOps. So all these are 0. Okay. Another concept is what things do I need to pay attention to? Well, if I scroll down, let's look at rework hotspots. A rework hotspot is work items where they just went back and forth, back and forth, back and forth, back and forth. They did a lot of movement. We spent a lot of work on them, but it took a long time to finish. And so if I pick one, let's see, spotter tool redesign. Let's just pick on it. All right, we can see what was its journey. Well, backlog to user experience design to development to functional validation. We actually did what we thought we were going to do. And then from functional validation, oh, let's go back to development. Let's go back to test design. And then, oh yeah, we're done. Let's go to done. Wait a minute, we're not done. Let's go to user experience validation. And then it's just like all over the place. And then and of course you can open the work item in Azure DevOps and you can see just what happened. But if you look at it, 2021 October to 2022 February, this guy churned for 4 months figuring out what should we do, how should we do it, but this shines the light on some of these things. A lot of people do retrospectives where, I mean, it's a good concept. Hey, you know what? Periodically, let's reflect on how we're doing and how can we get better? Well, when we have a retrospective, do we clearly see all these things like, man, is there anything common that caused these work items to just have a whole lot of rework and back and forth, back and forth, back and forth? Can we find any commonality? Maybe this is where we should figure out how to improve our process, right? Now you have some real data to fuel your retrospective meeting because there's a whole lot of waste. In this category, a whole lot of waste. All right, so clarity, what is happening? We have to have this type of tool. This is the clarity part of an AI software factory. The Dell factories in Round Rock, if the plant manager doesn't know that a certain type of computer or a certain line is, all the RAM chips are not getting seated and they're going back and failing the tests and really can't, all they see is Well, we need more workers on the line because we're not getting computers out fast enough. If they don't have any data on what's happening in the line, well, then they can't make good decisions, right? So clarity, we have to understand what's actually happening because until we understand it and then tuned the items we don't like, implementing AI is not gonna, we're gonna spend money on tokens, but we're not gonna get better. All right. This is the tool to help us know how we're doing now and how we get better. Okay, let me kill this and one more demo and then we're gonna be done. And I told you guys we're gonna be out of here at 11 and I stand by my word. All right, so we're gonna, not there. We're gonna move back and make this the startup project again. Control F5. Okay, so I talked about clarity, knowing what I have and knowing how it's going, right? I want to show you something in the vein of answering the question, what do I have? Now, it's not going to fully answer the question, but it's something in that category. All right. Come on. I don't know what the weather's like at my house. Okay, web front end. Let's open it up. Well, still not fully. I don't know what's slowing it down. Okay, I'm going to go over to the architecture module. Okay, so as software gets larger and we have more software systems, or even one software system that we've chosen to break up into autonomous services, whether we call it microservices or whether we have a distributed system that just has lots of parts, and then we have lots of people working on the different parts. And over time, it's hard for any one person to consistently remember the shape and the integrations and the dependencies of every piece of it, right? And so we have to be able to keep our balance sheet. What do we have? What is the shape of it right now? Do we have any elements of it that we don't like? And so one of the tools is just to be able to say, okay, we have to have that type of documentation always up to date. In other words, we have to automate it. Every pull request that changes something, okay, let's have an automated routine that automates it, because manual documentation updates, we all know it's not going to happen. If we want reliable views of our software besides the source code, it has to be generated automatically. So this tool just uses the plant UML or pummel files that are in the source control, and it renders them. And that's the system context. I know you can't really see from back there, but and then the container diagram for what's running. And so the AI software factory, we have something that's running here, and there's a few Docker containers. Then we have GitHub, which is a third-party system we integrate with. We have Azure DevOps, which is a third-party system we integrate with. We have Cursor AI Agent, which is a third-party system we integrate with. GitHub Copilot, Cappy. We have a Redis database for cache. And then we have the target application, that work order application. That's our target application that we're actually working on. And then we have, Azure DevOps adapter, GitHub adapter, custom adapter for if we're using Claude or IBM Bob or whatever. Okay. So as anytime code changes, well, guess what? One of the lines on this diagram could be out of date. The name of one of the boxes could be out of date. There could be a new box that spawns and it's not there. The good thing about plant UML diagrams or mermaid diagrams is they're text. And whether it's attached to the pull request, a trigger when we merge a pull request into master or wherever you choose to hook it in, this diagram was harvested from the code anyway. It's not like anybody had to manually produce it. So, okay, just a prompt. And so when the code changes, you have a prompt that reviews it all and looks, did anything change? Great, update it, done. But this is one example that in the AI software factory pattern, I encourage you to think about the concept of, do I know what I have? And the shape of the software system is part of that answer of knowing what we have. And and of course, you can have documentations of paragraphs. You're going to decide how many paragraphs are useful, how many pictures are useful. That's your decision, right? And so, again, there's runtime diagrams. I have the flow. No, hold on. Yeah, some sequence diagrams for how some really important flows happen. Whatever you find to be useful, you want some pictures. And if all of your documentation is only English, then I guarantee that there's opportunities for taking 1,000 of those words and replacing them by one picture. A picture's worth 1,000 words. Okay, let's finish up here. All right, so how do you implement an AI software factory pattern? You look for bottlenecks and process gaps. You evaluate the low-hanging fruit with the current AI tools you have access to, what could be, and treat the automation as a hypothesis. You don't know for certain that implementing those and spending money on AI tokens in a certain place is going to be good. It's a hypothesis, and you're going to run an experiment, and you need your optics, actual optics, your scorecard, so that you can measure before and after, and it happened. Also, you want to optimize, so you want to automate the simplest path first, okay? Artificial intelligence, it is artificial, but there is no intelligence. We are the intelligence, okay? And even the big expensive models that claim to have, certain reasoning, they have no wisdom. And the context window, even if they give us a million token context window, as a little infant, my infant brain, when I was 2 days old, had 100 million token context window. It is night and day, okay? So from a thought process, I encourage you to take the easy stuff and implement the easy stuff as we learn this new ecosystem, and let your own brain do the reasoning. Let your own brain make the decisions, and let the computer do what computers have always been good at. Really fast lookup, transforming things, doing repetitive tasks. When's the last time you did a Google search or a Stack Overflow search? The syntax is solved now. How do I get this library to do such and such? Oh, think about UI controls. How much time did we spend with UI controls that had 9,900 properties that affected how a chart or a grid would be displayed? And it's like, oh my gosh, how many cycles? Start the app, go to the start the app, change it, start. Well, now it's just, AI prompt. Okay. So there's a whole lot of things that will never be the same, but those are the easy things. Reasoning, there's a whole lot of time. YouTube is now cluttered with people, sharing stories of, I spent all this time and now I coded myself into a corner and now I'm just starting all over because now I can't even make sense of what's here because it was too big. We expected the computer to have some type of engineering wisdom, and it doesn't. But let's use it for what it's awesome for. So start with the easy stuff. And then continuous improvement loop. Again, a complete DevOps environment gives you that. All right. I already talked about the prerequisites for it. And so as a final reminder, the AI Software Factory pattern that I'm proposing is a leadership level orchestration pattern for clarity first, knowing what you have, knowing how it's going, then the ability to change, to alter the process and measure and know how it's going, implement AI and know how it changed your process, and then the ability to forecast into the future. If we change nothing, what could we do? If we change something, how could we do differently? All right. And I'll leave it at that. We're doing quite a bit of AI implementation. We're going to have another boot camp level AI class, I think this August. We did one last summer and we did one just here in February. So that's for very senior engineers and architects. So that's not announced yet. But I appreciate the invitation to come here and speak. Been a long time since the Austin.NET user group has convened in person, and probably an even longer time since I've been here and many of you. So it's great to be here and so we can